Hello. In this lesson we're going to take a look at prefixes, which are widely used in science and especially physics. Let's look at some examples to start with. Here's one I hope you're reasonably familiar with already. 44 kilometers. The K stands for kilo, which is a prefix going in front of the unit meter, and K means 1000. So when we write 44 kilometers, we mean 44,000 meters. And prefixes are used to mean multiples of a particular unit. Now the other examples you may not recognize, but let's just read through them anyway. 55 picoamps. Pico is a prefix. 12.2 nanometers. Nano is a prefix. 123 meganewtons. Mega is a prefix. 300 terajoules, tera prefix. 1.98 microseconds, the prefix is micro, and we'll talk about all of these as we go through. To start with though, we must understand some basics about standard form notation, sometimes called scientific notation. So let's quickly do that. The number 5.1 times 10 to the 5 represents this. 5.1 times, 10 to the 5 is 5 tens multiplied together. Just like 10 squared, 10 to the power 2 is 2 tens multiplied together. So this notation, 5 times 10 to the 5, is a way of representing 5.1 times 100,000 or 510,000. And this is called standard form or scientific notation. Negative powers of 10 sometimes cause confusion. Let's just go over a quick example. 5.1 times 10 to the minus 3. What does it mean? Well, 10 to the minus 3 means 1 over 10 to the 3. Let me say that again, it's critical. 10 to the minus 3 means 1 over 10 to the 3. So this number means 5.1 times 1 over 1,000, which is the same as 5.1 over 1,000. So it's 5.1 thousandths, which you can write in decimal form like this. Okay, you need to bear these powers of 10 in mind. Let's look at a number which uses a prefix, 44 kilometers. It's actually the product of three separate things. The 44 is a number. The M at the end is 1 meter, it's a unit, and the thing before the unit is a prefix. K means 10 to the 3, 1,000. So in fact, this means 44 times 10 to the 3 times 1 meter. And all we have to do is swap the K for 10 to the 3 to work out the value. Just write 44 times 10 to the 3. Here's another example. 1.2 milliseconds means 1.2. Milli means 10 to the minus 3. And we have the unit at the end, second. All we did was swap the M for 10 to the minus 3. And we've got the answer. We can write it out in normal decimal form if we want, 0.0012 seconds. Okay, let's go through the larger prefixes. They go up in steps of 1,000. So it's 10 to the 3, 10 to the 6, 10 to the 9, and so on. 10 to the 3, you already know, is kilo, small k. 1,000 times bigger, 10 to the 6 is a million. Symbol capital M for mega. 1,000 times bigger, giga, capital G. Some people call it a billion, but the word billion means different things in different countries, so you've got to be very careful. Next one up, 1,000 times bigger, 10 to the 12, is tera, capital T. And the first four are the most common ones. The remaining four, peta, exa, zeta, and iota, you can learn them if you want. That's what they mean. They're not as frequently used as the first four. Let's look at the small prefixes. We already know that milli means 1,000th, not a millionth, by the way. Milli means 1,000th, 10 to the minus 3, small m. 1,000 times smaller takes us to 10 to the minus 6. And the symbol for that is a mu. The prefix is called micro, and its symbol is a mu, which is a Greek letter. When you write it, it's like a U with a tail on the left. That's a millionth. 1,000 times smaller than that takes us to 10 to the minus 9. That's nano. 1,000 times smaller than that, 10 to the minus 12, pico. 1,000 times smaller than that, minus 15, femto. And so on, all the way down to 10 to the minus 24, yocto. In fact, only the first 4 or 5 are used commonly, but there they all are if you want to learn them all. Let's look at a particular example. Suppose you want to know the frequency in hertz, and you're told the frequency is 14 terahertz. What does that mean? Well, all you have to do is replace a t, tera, by 10 to the 12. So that is 14 times 10 to the 12. And on the calculator, you would enter 14. The X key might be different on your calculator, but it means 10 to the power, and then you enter the 12, just like entering a standard form number. You'll notice I've missed out a bracket at the end of that, so well done. There are other prefixes, 10 to the minus 1, deci, 10 to the minus 2, centi, as in centimetre. They are not the official ones, which go in 10 to the 3s, 10 to the power 3, 10 to the power 6 and so on, but you will come across them frequently. Let's just look at it the other way around. Let's see how many milliseconds there are in 1 second. Well, I hope you realise 1,000 milliseconds is 1 second, because a millisecond is 1,000th of a second. There are a million microseconds in a second. There's 1,000 million nanoseconds in a second. So all we have to do, if we want to convert from, for example, seconds to, for example, nanoseconds, is multiply by 10 to the 9, because that's the number of nanoseconds in 1 second. Multiplying by 10 to the 9 is the same as dividing by 10 to the minus 9. Let's do an example. Suppose you're told the time is 3.6 times 10 to the minus 5 seconds, and you want to turn it into microseconds. Well, to turn seconds to microseconds, you've got to multiply by 1,000,000, because there are 10 to the 6 microseconds in a second. And if we do it, it's pretty straightforward. It comes to 36 microseconds. Let's do a proper calculation. A proton travels 50 picometers in 12 femtoseconds. What's its speed in meters per second? Well, speed is distance over time. If we want the speed in meters a second, the distance must be meters, the time must be in seconds. So we put the distance in meters. We don't write 50 pm, we write 50 times 10 to the minus 12, because pico is 10 to the minus 12. If we want the time in seconds, we've got to replace the f, which is femto, by 10 to the minus 15. So we write 12 times 10 to the minus 15 instead of 12 femtoseconds. And we do the calculation, pretty straightforward, you do it in your head, and the answer is 4,200 meters a second, or 4.2 kilometers per second. That was it. I hope you now have a good grasp of prefixes.